Hey guys, we're going to do another chapter 3 video here, and for your notes today you're going to have to write your own essential question and date and kind of set that up because we're going to dive basically straight into this problem. And the question is this a function? So we've got a table with some x, y values, and if you need to pause the video to kind of sketch the table and copy some of this down, go for it. And the table kind of has some sporadic numbers. We have x equals 10, -8, +4, and +6. And here are our outputs: 0, -9, -3, and -2. And what we're going to work on in this video is how can I take this question from just answering it to going above and beyond and really stretching my brain so that I show a lot more of my thinking. So the question is it a function? So functions, we know every input has one output. So when I'm looking at the table here, my first thought is, well, my inputs are my x's, so I think I'm going to add that to my label, and my outputs are my y's. And every input has one output, and in this case, absolutely, every input has one output. Unfortunately, I wish one of the numbers repeated, like if 10 showed up again in the table, I would expect to still get a 0, as if it's a function, it would still come out 0. But given just what I have here, to me it looks like every input has one output. So I could just answer, I could say, looking at the table, so we're going to write looking at the table, I notice every input has one output. Looking at the table, I notice every input has one output. Therefore, this is a function. This is a function. Therefore, this is a function. Now, technically, I'm done. I've answered my question. I feel comfortable in my answer, so I could stop here. But like I said, we're trying to stretch our brains and we're trying to go farther with this. So I'm definitely going to go farther today with this. So I'm thinking if I really want to prove my answer, why don't I prove it graphically? Why don't we look at these points on a graph? And so that's my next step down here is I'm going to sketch a graph with these coordinate points. Now, if you look at the table, the x's go from like -8 to 10, so we have a pretty big x-axis here. So I'm going to make sure when I grab my ruler that I set up a really long x-axis that can reach 10 and -8. So let's go like here, like that. Let's see, hopefully that is long enough. That's my x-axis. What was the biggest number I needed to get to? Wasn't it 10? So if this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, here's 0. And then -1, -2, -3, -4, -5, -6, -7, -8. I barely made it to -8. I'm doing that because in my table values, -8 and +10 were the smallest and largest number. So I know my graph has to stretch that far, and I just barely made it. For my y-axis, 0 is the biggest number. They're all negative numbers. So what I'm going to do for my y-axis is it'll be kind of short on top, but definitely lengthy going down, kind of like this. Okay, so let's fix this up and get some more detail on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do -1, -2, -3, -4, -5. I just want to get all these numbers on here. -7, -8. Same thing going up. 1, 2, 3. I didn't go very far on the y-axis. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. I'll stop there. All right. So if I went fast, pause video, set your graph up. Here's what we're going to do. We are going to prove that this table is a function by looking at it with another strategy, by graphing it. So we're going to plot the points from the table. So I'm going to start with the first point that's up here in the table, which is at 10 and 0, which means on my x point, I have to go all the way out to 10, but then stay at 0, so I'm actually on the axis right there. Now the next point I need to graph, let's see, going back to my table, is -8, -9. So that means -8 means I'm going to go way back to -8 and then way down to -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, way down here. There it is. Wow, these points are spread out. Okay, let's do some more. So let's see, I have 4, -3, and 6, -2. Let's get those on the graph also. So 4, -3 means 4, down 3. And 6, -2 means here's 6, -2, be like right there. Those are a little closer together. Actually, if you look really closely at this, it kind of looks linear to me. In fact, my ruler, gosh, I kind of have a short ruler here. Doesn't this look like a perfectly straight line? I barely have enough ruler length to reach it, but it does look like a straight line. Absolutely. Let me go get my other longer ruler and we'll double check it. All right, so longer ruler, just to verify, that ruler is not my favorite right now. Yeah, this looks very linear to me. So what I'm going to do is I'm going to connect my points in this nice straight line as best I can. There we go. Draw some arrows on here. And what was our question? What were we supposed to be proving? Oh, we were supposed to be proving that it's a function, that it passes the vertical line test, that it only has one input. Each input only has one output. So this one definitely looks like a function. It looks like a line, in fact. If I drew a vertical line, it only will hit the graph one time at one location. So this one passes the vertical line test. Passes the vertical line test. And what that tells me is it double verifies, yeah, this is a function. Like if it can pass the vertical line test and every input has one output, we're kind of double proving it. So how else could I take this farther? Now that I've shown that the table has, every input has one output and it passes the vertical line test, what else could I do with this problem? Well, it is a linear line, so I could write a function. How about we make a growth triangle and try to find that slope? Let's try to figure out what y equals mx plus b would be for this. Now the m, the slope, is going to be found by calculating what rise over run is. So we know we're going to need to figure that out. And then the b, the y-intercept, well, maybe we can just look at the graph potentially. In fact, look at the graph. If you used your ruler and you were very careful, it looks to me like the y-intercept is right at -5. I'm going to label this y-intercept. So if -5 is my y-intercept, then I think we just figured out what b is. I think it's going to be -5. So I'm going to put that right here. Let's find our rise and run. We need to pick 2 points to make a growth triangle. You can choose which points you want to use. Like we could make a huge growth triangle from beginning to end if you wanted. I'm kind of thinking the littler ones might be closer. So that's what I'm going to do, is use these little ones that are closer together. I'm going to make my little growth triangle here. It looks like, if you look carefully, it goes up 1 over 2. So my rise and run look like up 1 over 2. Here, I'm going to shade that in so we can see that. So rise over run equals up 1 over 2. So it looks like a slope of a half. 1 divided by 2 is a half, basically, or 0.5. So if I had to write an equation, I would say it is y equals 1/2 x, and then we said -5. And there's my function, there's my slope. Now look how much farther I took this problem. I mean, all I had to do is say, is this table a function, yes or no? And I could have just said, every input has one output, and then ended it right there. But I really went above and beyond, and that's what we're trying to do in class. We're trying to push ourselves to be like, really proving ourselves and justifying like what we know. So yeah, I can tell from the table it's a function, but check this out. I can visually show you too. I can show you that it's a linear line, that it passes the vertical line test. I can calculate the slope. I can write the equation. So I'm going to add a little note up here that this is a linear function. So maybe we'll put it down here actually. Based on the graph, this is a linear function. This is a linear function. Based on the graph, this is a linear function. I know this because the coordinate points are in a straight line. I know this because the coordinate points are in a straight line with a slope of 1/2. Based on the graph, this is a linear function. I know this because the coordinate points form a straight line with a slope of 1/2. Now I feel good. I try to keep thinking, what else can I show? What else can I show? Well, now I've written a pretty good statement to go with my graph. Sorry, that's a school bell. I've written a pretty good statement. I've written an equation, y equals mx plus b. I've labeled my growth triangle. I've labeled my y-intercept. My graph is nice and neat, easy to read. I've shown that it passes the vertical line test. And way back at the beginning, I studied the table and explained the input-output situation. So that's going above and beyond. That's really pushing to that level 4, that advanced level. So this is what I'm hoping to see from you guys in class. I'm hoping I'm going to start noticing on exit tickets and quizzes and on team tasks that you're starting to push yourself to be like, I don't want to just answer the question. I want to show my level 4 work. I want to put everything I know into this problem and really take it to that high level thinking, because you'll be amazed at some of the stuff you might come up with and think of as you do that. So I'm encouraging you now in this video, go for that advanced understanding. Show me everything you can related to a problem. And if that doesn't make sense, we're going to work on it in class too, but hopefully the video makes a little bit of sense. Thanks for watching, guys. I'll see you in class. Bye.